Welcome to today's session on how do I solve nonlinear polynomial equations. First, let's discuss what does it mean to be nonlinear. In a previous session, we discussed that to be linear means that the degree of the expression, equation, or function is 1. So what does it mean to be nonlinear? Well, a nonlinear polynomial is a polynomial whose degree is greater than 1. Examples of nonlinear expressions, equations, and functions, we see that the degree of each is indeed greater than 1. So how do we solve nonlinear equations? First, we want to make sure that we set the equation equal to 0. This is done by simplifying both sides of the equation if necessary, and using addition and subtraction to move all terms of the equation to one side. After we've set the equation equal to 0, we want to factor the polynomial if possible, set each factor equal to 0, and solve the individual equations. Let's look at an example. If you're given x squared minus 4x equals 5, first, does this qualify as a nonlinear equation? If so, what is the degree? We see that this is indeed a nonlinear equation, and if we want to set it equal to 0, we would subtract 5 from both sides. What about this? We said sometimes we have to simplify both sides of the equation. So if I'm given the quantity x minus 2 times the quantity x plus 1 equals 4, I would have to FOIL the left-hand side, thus giving me x squared minus x minus 2 equals 4. Subtracting 4 from both sides of the equation, we would get x squared minus x minus 6 equals 0. And thus, the equation is set equal to 0. Number 2, factor the polynomial if possible. So we see that x squared minus 4x minus 5 equals 0 can be factored into x minus 5 times x plus 1. We then set each individual factor equal to 0, and we solve each individual equation, getting x equals 5 and x equals negative 1. So let's look at an example and do one on our own. What if I give you the quantity x minus 3 times the quantity x plus 4 equals negative 6? First, let's think about what's our first step. And second, go ahead and solve the equation. Let's see what you get.